Hi there, this is Professor Eckhouse, and I'm going to talk today about rationalizing denominators. We're going to start with multiplying binomials that contain radicals, and then we're going to learn how to use that to rationalize. All right, so just a little warm-up. Pause the video and multiply those two binomials together. Okay, so hopefully you remembered to FOIL it. So first is these two. You're going to take 3x times 3x, times 2x. And then we're going to do the outside term. So minus 3 times 3x. I just choose the order that makes most sense to you. That's the outside term. And then the inside term is going to be plus 4 times 2x. And then the last is going to be 4 times negative 3, or minus 3 times 4, however you want to think about it. So it works best in your brain. So 6x squared is our first term. Minus 9x plus 8x minus 12. And we get 6x squared minus x, because it's a minus 1, minus 12. Okay, so notice that the middle two terms combine together when we set it up as FOIL. The O and the I, the OI terms, are going to combine together. All right, so multiplying a two-term radical expression, you're going to use the distributive property. Sometimes you'll get to use FOIL if it's two binomials. And then remember that if you take the square root of a times the square root of b, that's the same thing as the square root of ab. And then always combine like terms, which we practiced doing last time. All right, so just a little refresher here. The square root of x times the square root of x is the square root of x squared. So hopefully you begin to recognize then that you just get x. Notice how that is different from square root of x plus the square root of x. In this case, we have basically a coefficient of 1. We don't have to write it down, but it's there. So we have 1 square root of x times plus another square root of x. And we're adding the two together, and we get 2 square root of x's, or 2 square root of x. All right, so you try those two and notice the difference. Okay, so for the first one, 2 times 4. And then times the square root of x times x, or x squared. I wrote it above as x squared, this times x. Be flexible so that either way you see it, you'll understand that it means x. The square root of x times x is x. All right, notice the difference. This is a plus. So 2 square root of x's plus 4 square root of x's. 2 of something plus 4 of something is 6 of that something. 6x. Different answer. So 6 square root of x in this case, and this one we get 8x. So the square root goes away on the first one because we're multiplying. All right, so multiply the following. We've got 3 square root of x plus 2 square root of x. Now, do not skip anything here. All right, I'm even going to color code this. So this is our first term, and we get 3 square root of x times 2 square root of x. All right, now I'm going to scoot this down so I have a little bit of room to do all of this. I'm going to use multiple colors. All right, so we've got, let's see, I'll use that one. So outside is this one right here. So we're going to have a minus, right, a minus 3 times 3 square root of x. I usually try to put my number that's alone in front. All right, then we've got the inside term. So we've got plus 4 times 2 square root of x. All right, then we've got the last one, minus 3 times 4, or negative 3 times 4, like that. All right, so let's take this one step at a time. Be very careful. Lots of things to mess up. 6x times 6 square root of x. Oh my goodness, I'm getting ahead of myself. 3 square root of x times 2 square root of x is going to give us 6 square root of x times square root of x. So I'll do this the long way just to make sure I don't lose anybody here. So it's going to end up being x. But just think about the square root of x times the square root of x means the square root of x times x. All right, minus 3 times 3 is 9 square root of x. Plus 8 square root of x minus 12. All right, so we end up with 6x minus, I'll just do this in black, minus 9 square root of x plus 8 square root of x is minus square root of x. And then we've got our minus 12. Now I want you to compare and contrast this to our warm-up up here that we did. Very, very similar. We just had to deal with square roots. Okay. So let's try one with cube roots and squares and anyway, it's all over the place. So be really careful. There's a lot of stuff going on here. Color code, take things a step at a time, whatever you need to do. So we're going to take this one times this one. So I've got 2x squared times the cube root of x squared. All right. Plus the outside terms. So plus 3 times 2x squared. Plus the inside terms. And that's going to be the cube root of x times the cube root of x squared. And then the last is going to be the cube root of x times 3. So I'm going to actually put the 3 up front. Fix that a little bit. So we got plus 3 cube root of x. All right, so is there anything we can do with any of this? The first one, no. The cube root of x squared, nothing we can do with it. So 2x squared cube root of x squared plus 6x squared, change colors, 6x squared plus, now we've got the cube root of x cubed. So the cube root of x cubed, instead of writing all this all over again, I'm just going to go like this. That's x. All right, plus 3 cube root of x. All right, and you could erase that and put the x in and everything if you want to, or you could rewrite it if you'd like. Okay, let's look at some more. Rationalizing denominators. The goal is to eliminate a radical in the denominator. So we don't like radicals in denominators because they are irrational. They're generally irrational. So rationalize means to eliminate the irrational number in the denominator. An irrational number generally is a square root or a cube root. So radicals are often irrational if they're not perfect squares. So in red here I have a key fact. Square root of x times square root of x is square root of x squared, which is x. We've just been practicing that. So make sure you've got that. When you take the square root of x times the square root of x, you just get x. And I may not take those through lots of steps anymore, now that I've said it. So let's rationalize the denominator. Let me show you the technique. All right, so the goal here is also another key fact that I left out because it's a little more basic. A over a is 1. So we can multiply any fraction by something over itself because it doesn't change the value of the fraction. All right, so in this one, we're going to choose to do square root of 2 over square root of 2 because of this key fact right here. Yay, we get to do that, and it makes the square root of 2 on the bottom go away. Okay. All right, so we then get 1 times the square root of 2 on top, which is the square root of 2. And the square root, now I'm not going to write this out every time, but I want you to see the square root of 2 times the square root of 2 on the bottom. Now don't go canceling because we just are uncanceling right now. So we get the square root of 2 on top, and on the bottom square root of 2 times square root of 2 is just 2. So these two, this one and this one, they are the same value. If you put them in the calculator, you will see they are the same number, but this one is the second, the one I have a box around, is rationalized. Okay, they're the same number, but the second one is rationalized. It does not have an irrational denominator. All right, so let's rationalize this denominator. So give the first step or two a try. See if you can do it. All right, so I'm going to multiply the top and the bottom by square root of 5. Because square root of 5 times square root of 5 is just 5, and the square root will go away. But take this a step at a time, because now on the top we've got to distribute this to both of these. Be careful, take your time. We've got 3 square root of 5 plus square root of 5 times the square root of 5 over square root of 5 times the square root of 5. Now, as you get better at this, you don't have to write so much, because you'll see square root of 5 times square root of 5 is just 5, right? Square root of 5 times the square root of 5 is just 5. And then on the bottom, another 5. Okay, so now, pencils up. Don't write for just a moment. I want you to just think. Don't write this down. Can I cancel those out? Absolutely not. You cannot. There is a plus sign here. There's a plus sign. You cannot cancel across a plus sign. It is not a factor. It's a sum. We can only cancel factors. Okay, try it with a number. You'll see. It does not work. It does not give you the right answer. Okay, so that's our final rationalized number. Now these again are the same. If you put them in your calculator, you'll see that they are the same, but this one is rationalized. All right, now we're going to start working with variables. So rationalize this denominator following the same exact steps that we just did. Pause the video and give it a try. Okay, so what you're going to do is multiply the top and bottom by this right here, like we did before, the square root of x over the square root of x. All right, again, take your time, because there's a lot of stuff to mess up here. So we're going to take this a long way, and some of you may see square root of x times square root of x. Oh, that's just x, but I'm going to write it down. All right, now I'm going to put this in alphabetical order, so I'm going to put the square root of x first times the square root of y. Okay, so I just took this and I distributed it across here and here. That's what I just did. So pause the video if you need to and think about that. All right, that is all over square root of x times square root of x. So every time I write square root of x times square root of x, what do I get? I get x. Plus now, when two things have the same index, which is a square root, they can go together underneath xy over x. Okay, so can I do this? No, no, no. There's a plus sign. Don't do that. And that's your final answer. That is the rationalized version of that. All right, another one. Rationalize the denominator. My first hint, though, for you is to rewrite this as the square root of 64x over the square root of 5y. Then you'll see that there's a square root on the bottom. All right, now I'm also going to rewrite this. Square root of 64 is 8. So I'm going to go ahead and take it out over square root of 5y. So if there's anything you can take out, go ahead and take it out. It just keeps your numbers smaller to deal with. All right, now I'm going to multiply top and bottom by what? Square root of 5y. Okay, so see what you can do with that. Pause the video if you only got this far and see what you can do with it. All right, so on the top, you have an 8 on the outside, and you can combine everything because it's all a square root index. So I'm going to put it in alphabetical order. X times 5y is 5xy. We usually put the number first, even inside. Over square root of 5y times square root of 5y is just 5y. And that's your final answer. Can you cancel the 5 on the inside and the 5 on the outside of a radical, and the y on the inside and the y on the outside? Absolutely not. They are not the same thing. The square root of 5 and 5 do not cancel with one another. So this is your final answer. And this is the rationalized version of that. All right, so rationalize denominators with two terms. All right, so what you want to do is we're just going to practice foiling one more time, and I want you to see what happens when we have x plus 3 times x minus 3. Some of you may remember from our special factors, but go ahead and try both of these. Okay, so for the first one, hopefully you got x squared plus 3x minus 3x, or the other way, minus 3x plus 3x minus 9. So that means these two are going to cancel out because they subtract away, and we get x squared minus 9. So what happens with this one? Square root of 2 plus 3, square root of 2 minus 3. All right, well, I'm going to take this a little longer. Square root of 2 times the square root of 2. Hopefully you know what that means now, but I'll do this in the FOIL order, sorry. In fact, I should go do the other one. I just grab them and do them, but I'll do the outside first. That would be a minus, and the inside is a plus. So let's do the outside first. That's these two. So minus 3 square root of 2, and then the inside, that's those two, plus 3 square root of 2, and then the last is minus 9. Look how similar that is. So what happens to the 3 square roots of 2? We've got a minus and we've got a plus, so they cancel out. And the square root of 2 times square root of 2, what happens to it? It becomes a 2. And we get 2 minus 9, which is just negative 7. Square root's gone. All gone. All right, so that's what we're going to do with these. So this is called a conjugate. The conjugate of square root of 2 plus 3 is square root of 2 minus 3. Those are conjugates of each other. Conjugates. You can go either way. It's a binomial, it has two terms, and there's a plus in one and a minus in the other. So what is the conjugate of square root of x minus 5? Let's try all of those, because we're going to use the conjugate to rationalize the denominator if it has two terms. All right, so for this one, the conjugate is going to be the square root of x plus 5. And you can put parentheses around it if you want, so it really looks like a binomial, because it is. All right, and this one is going to be 7 minus 3 square root of x. Notice you don't change the first term. You only change the sign in between the terms. Don't change the first one. It stays the same. All right, so just change the sign in between the two terms, and those are conjugates. Okay, so these are conjugate pairs, right, with each other. All right, we're going to use these to rationalize the denominator if it has two terms. So let me just go back up and show you again. We were rationalizing things with one term on the bottom. There's not any addition and subtraction in any of these denominators. So now we're going to see some that have denominators that have two terms in them like this. So what we're going to do is we're going to look at this right here, and we're going to multiply the top and the bottom by the conjugate of that, which is 5 minus the square root of 7. 5 minus the square root of 7. Okay. So be careful. We've got, let's see, two binomials and we're multiplying together. So you have to FOIL these and you have to be really careful because there's a lot of places to mess up. So I'm going to take this one step at a time. 3 times 5. All right, that's the first. And then the outside is minus 3 square root of 7. The inside is minus 5 square root of 5. And the last is minus square root of 5 times square root of 7. Yikes, what a mess. And then on the bottom, we get, so now you will learn to do this without doing it the long way, but we're going to do it the long way for a little while. We get 5 times 5. I'm going to do this in a different color so we can really see the difference between the top and the bottom. So we've got 5 times 5. All right, the outside is minus 5 square root of 7. And the inside is 5 square root of 7. Look at that. And then the last is minus, because there's a plus and a minus multiplied together, square root of 7 times square root of 7, which is what we were going for. It's going to go away. All right, so we've got 15 minus 3 square root of 7 minus 5 square root of 5 minus the square root of 5 times 7 is 35. None of those are like terms. We cannot combine them, which is why we did that first, right? All this is building. One thing leads to the next. All right, on the bottom, I've got 25, and then these go away. Minus 5 square root of 7 plus 5 square root of 7. and then minus 49. All right, 25 minus 49. Sorry, not 49. I think I'm getting tired. It is not 49. What is it? Square root of 7 times square root of 7 becomes square root of 49, which is 7, right? So 25 minus 7. All right, so 25 minus 7, this right here becomes 18. I'm not going to rewrite the whole thing. All right. Any questions? Ask me in class. All right, we've got one more to go, I believe. Yep, just one more. Rationalize the denominator and simplify. So give this one a try. All right, so the bottom is square root of x plus 5, so we need to multiply top and bottom by square root of x minus 5. Square root of x minus 5. All right, so we are going to distribute with FOIL or just distribution, and we get square root of x times square root of x, and you may see that that's just x, minus 5 square root of x on top, and on the bottom we get square root of x times square root of x. Let's just do this. Square root of x times square root of x is x. And then we get minus 5 square root of x plus 5 square root of x, and they go away, right? And I'll write it one more time. Minus 5 square root of x plus 5 square root of x. But they're going to cancel out. So if you can see that, when you're rationalizing, it's going to go away if you do it properly. All right, and then we've got minus 5 times 5. Okay, so on top we got square root of x times square root of x, x, minus 5 square root of x, over x, which was square root of x times square root of x, minus 25. Can we cancel the x's? Can I go like this? No, no, because there's a minus, right? There's a minus on both of them, so you cannot cancel things out. Cancel factors. Factors are multiplied. And that's the final answer. So this only works. The ones with the conjugates only works for index of 2. Not cubes or to the fourths or roots like that. So I should have said cube root or fourth root. You can't do anything above 2. So these, using the conjugate method, only works for square roots. All right, that was it. Thanks for watching.